Hey everybody, Arturo Marchand here, SSI XRI and DMI, number 296247. We're going to spend some time today on how to plan your dive for gas consumption properly. There's a few concepts that we must talk about before we get into it. It's sometimes very important, and I find that a lot of people don't have this knowledge. They didn't gain it through the typical open water course and the subsequent specialties. This is more of something that people learn when they're doing some technical dive planning, but it's very applicable to your everyday diving life. So let's start by talking about cylinder capacities. Everybody knows, not everybody, I say a lot of people know that there's different cylinders out there. There's aluminum cylinders and there's steel cylinders. There's other types of cylinders, but not typically used for diving. Aluminum cylinders vary in size from 6 cubic feet all the way to 100, and steel cylinders are typically higher in capacity, although there are high pressure cylinders that are serviceable to 3442 psi's, and then low pressure cylinders are typically 2400 plus an additional percentage over if they get the stamp when they get hydroed. That's usually 2640 total capacity. The important part is that the pressure and the size of the cylinder determine the amount of volume of gas you can put in each of the cylinders. So one cylinder's PSI level or pressure is not the same as another's, meaning that 100 PSI in an aluminum 80 is not the same volume of gas that 100 PSI in a steel 100 is. We'll get into that next. So tank factors affect the gas volume of the cylinder. And that is a calculation that's done with the capacity of cubic feet divided by the working pressure, multiplied by 100, so that we use it 100 psi blocks, will give you a number that you can use to move psi to cubic feet and cubic feet to psi's within a particular size of cylinder. First example here is an aluminum 80, which actually has around 77 cubic feet of gas in it. It's a misnomer. So we take 77, divide that by 3,000, multiply it by 100, and then we get 2.5. So the tank factor for an aluminum 80 is 2.5. So you want to round to the more conservative number. Example 2, we have a steel low pressure 95 with a 10% plus rating on it. So that's 95 cubic feet divided by the working pressure, which is 2640, multiplied by 100, and you get 3.5. If we double up cylinders, you get double the tank factor. So steel 100s, that's high pressure steel 100s at 3442, 100 by 3442 times 100 times 2 equals 7. So what that means is 100 psi in an aluminum 80 is 2.5 cubic feet. 100 psi and a low pressure 95 is 3.5 cubic feet. And 100 psi in double high pressure 100s is 7 cubic feet. So if we start doing some examples here, and you have pressure, so not a full cylinder, you want to know how many cubic feet of gas you actually have in it to be able to then use your consumption rate to calculate when you have to leave the bottom. Well, you take the working pressure, you actually take the fill pressure, so that's 2,900 in this case. We're going to divide that by 100. This is aluminum 80. We know the tank factor is 2.5. You make that multiplication, solve the formula, and you get 72.5 cubic feet. Now, I'm sure you've been out in the world and you hear that certain technical divers, especially cave divers, we like to fill cylinders beyond the stated maximum fill pressure on the cylinder. I don't recommend you do this, but it does happen. So if you were to have a set of low pressure 95s, which is a tank factor of 7, and those are typically rated with a plus to 2640. If instead you overfilled those, dangerous, to 4,000 psi, instead of having the rated 190 cubic feet, you'd have 280 cubic feet of gas on your back. So again, this is one of the benefits of knowing this formula is you can go backwards and forwards between psi and capacity, so that if you have people diving with dissimilar cylinders, or you yourself have used up some of the cylinder, you can actually calculate the volume that you're going to need for your ascent. We'll get into that in a moment. and then match it up to your gas strategy for that cylinder. Well, before we get into calculating your consumption rate, we have to talk about and review what absolute atmospheres is. We know from earlier classes that when you descend in the water column, water pressure increases, which means that through gas laws, in this particular law, Boyle's law, there's going to be a change in the density of the gas. So there'll be more gas needed to fill the same volume. So when you breathe, your consumption is going to increase depending on your depth, just by the nature of how much more gas it takes to fill the same volume. To calculate the atmosphere's absolute, we're going to take the depth, divide it by 33, and we're going to add 1 for the atmosphere above our heads. So in this case, 85 feet is 3.57 atmospheres absolute. So it's 85 divided by 33 plus 1, we get 3.5 ATA. 66 feet divided by 3 is 2 plus 1, 3. So you're at 3 atmospheres, and so on and so forth. Surface air consumption versus RMV or SCR. These are two different concepts that are conflated quite frequently. A surface air consumption rate, or SAC rate, you hear it all the time, is expressed in a PSI per minute expression. Means that you breathe X amount of PSIs per minute. But like we shown earlier, that consumption rate is dependent on the cylinder. So what may be 100 PSI per minute on a aluminum 80, which would be a lot, but this is for easy numbers, would mean something entirely different if you had 100 PSI consumption per minute in a different cylinder. So what we do is we convert your PSI per minute consumption rate to an RMV, or respiratory minute volume, or SCR is another term you hear, surface consumption rate, and that's expressed in a volume per minute. So that would be some cubic foot per minute consumption. So how to calculate that? Number one, you're going to want to dive at a constant depth. Number two, you want to record the PSI, or the delta change. So if you started, as an example, with 3,000 PSI and an aluminum 80 and you're at 20 feet, well, now you can start doing some calculations. So swim around, average at that depth, and then get your consumption and get your average depth, and we can start doing the calculations. Example here below. So 600 PSI in an aluminum 80 is going to equal 15 cubic feet of consumption. How do we figure that? Using the formula that we studied above. That's 600 PSI as usage. We divide that by 100, and then multiply by the tank factor. So that diver used 15 cubic feet. 15 cubic feet in 15 minutes means 1 foot per minute. Now let's normalize that to the surface. So if the average depth was 33 feet, which means we're at 2 atmospheres, we're going to divide that by the absolute atmospheres. And that's going to give us a 0.5 cubic feet per minute. So that number now we can start using in any cylinder we dive, and we can start using to calculate how much volume we need for our dive. So how do you determine turn pressures? It's important. Well, several factors can determine a turn pressure. Number one, you've reached your bottom time. So if you're doing a no decompression limit dive and you reach the time you have to leave the bottom, well, that's one way to turn it. If any member of the team reaches a turn pressure, then that determines that the rest of the team is going to go back to the exit with, as a group, as a team. If any team member calls a dive, meaning that anybody can call any dive for any reason without any repercussions. That could be boredom, could be cold, could be feeling uneasy. Any time your dive buddy or your dive team gives you a thumb up, that means that everybody's going to get together and we're going to exit and get out of the water. Or the last one would be, hey, we completed our objective. We wanted to go down here and take a picture of X fish. We found it. Dive's over. Let's head back up. Now, how are turn pressures determined? Well, there's a really important concept. It's called minimum gas. And this in recreational diving is different than technical diving. So I'm making this for the recreational diver. But imagine the minimum amount of gas that myself and my dive buddy would need to have to reach the surface from the deepest portion of the dive. So with that, we add a couple of different permutations to make sure that the volume is enough. So we're going to calculate at 0.70 cubic feet per minute, which is probably a little bit on the higher end of the average consumption out there. And you're determining that because somebody's probably going to have some stress. If somebody's out of air and you have to share air, there's going to be a stressful environment. We're also going to add a minute to sort the problem out. So your dive buddy comes up to you, gives you the out of air signal. You're going to have to say, well, hang on a second. Let's share air. Let's connect arm to arm. Let me make sure you're okay. All right, we're breathing. Okay, let's head to the surface and let's measure our ascent rate by watching our computers and go all the way up, skipping the safety stop. And that ascent rate is going to be 30 feet per minute. So that's half a foot a second. And then that volume we're going to add to your 500 PSI reserve in your cylinder. Why do we have that number? Well, it's a number that we use because the standard SPGs or the brass and glass SPGs, the mechanical ones, are notoriously inaccurate below 500 PSI. So we don't really count that as volume. We need to know how much you and I need to get to the surface safely. So to do so, we're going to use the CAT formula, which is going to be consumption. So your 0.70 for this calculation. You're going to use your average pressure of the ascent, because you're not spending the entire ascent at the bottom, and you're not spending the entire ascent all the way at the 0 feet. Somewhere in the middle. So we're going to normalize that ascent to get a really good number on how much gas we need according to the consumption change with pressure and the time, and that's going to give us minimum gas. So in this example, we have 2 divers, right, as a dive buddy team and part of the team, not a 3-person team, a 2-person team. And everybody's diving a single aluminum 80 to 60 feet. So the consumption is going to be at 0.70 times 2, which is 1.4 cubic feet per minute. The average ascent depth, if we're at 60 feet, everybody follow so far? The average is going to be 30 feet. So we're going to take 30 feet, we're going to divide that by 33, we're going to add 1, and we get 1.9. So the average ascent depth, so the ascent depth that we're doing, our average ascent depth is going to be 1.9 ATA. If it was 100 feet, the average ascent depth is going to be 50. If you're doing technical diving and you're going to the first stop, you're going to use the average ascent to that first stop. But it's recreational diving. We're focusing on a no stop all the way to the surface. And in an out of air emergency, we're skipping the safety stop. So the time of the ascent, if it's 60 feet at 30 feet per minute, that's 2 minutes. To that, we're going to add 1 minute to sort things out. So our ascent is going to be 3 minutes total. So that's minimum gas of 1.4 times 1.9 times 3 gives us 7.98 cubic feet. In an aluminum 80, if we recall from before, we're going to take the tank factor, divide by 2.5, and multiply by 100. And that's going to give us 320 PSI. So for 2 divers, with an average consumption rate of 0.7 each, we'll need 320 PSI, or thereabouts, to reach the surface from 60 feet. So let's add that to our reserve. That would be 820 PSI. I'm calling minimum gas any dive shallower than 60 feet, 800 PSI. So at 800 PSI, you should be on your way up to the surface. Let's do another example. So let's call this one 100 feet. Same 2 divers, same average consumption rate, same aluminum 80s, except in this case, the average ascent pressure is going to be 2.5 ATA, and that's 100 feet divided by 2, which is 50. 50 divided by 33 plus 1 is 2.5. In this case, it's going to take us 4 minutes and 30 seconds. So that's 1 minute to sort it out, 3 minutes and 30 seconds for the ascent. To get the minimum gas calculation, 1.4 cubic feet, just like before. We have 2.5 atmospheres absolute. We have 4 minutes. That's 14 cubic feet. I say 4 minutes because the difference between 4 and 430, and we'll talk about it in a moment, is going to be negligible in this case. So that's 560 psi. To calculate that, you get your 14, you divide by 2.5, multiply by 100, and that's the number you get. So 2 divers sharing a cylinder will require 560 psi to reach the surface from 100 feet. Minimum gas, again, is going to be your ascent gas plus your reserve. So in this case, you notice I actually rounded up to 1100 psi. Because the ascent is borderline 430, it'll be easier to do the math and then round up to calculate for that 430. So you can actually do this calculation in your head. It's significantly easier to divide by whole numbers than it is to divide by half numbers. So that's the reason that I called the ascent 4 in the minimum gas calculation. But then at the time of making the minimum gas, I took the 560 and I actually rounded up. So that's 600 plus 500 equals 1100 psi's. So if you're diving to 100 feet, you should start heading up at 1100 psi. So how does that apply to a dive? Well, it depends. It depends on the gas rules. And there's 3 gas rules. It's all usable gas rule. There is the rule of halves, and then there is the rule of thirds. And in recreational diving, here's how I applied these. So all usable gas means that at any point during the dive, somebody reaches minimum gas, you can ascend to the surface, and it is both safe and convenient. So a good example is one of our local quarries here, Fantasy Lake Scuba Park. If at any point somebody reaches 800 psi, you can thumb it and ascend. In the worst case scenario, you'll have a longer than normal surface swim. Safe and convenient. No issues there. Another really good example would be if you're doing a drift dive, say in Cancun. The boat is following you overhead. Somebody reaches minimum gas. The entire group then ascends. The entire group then does their safety stop. And then the entire group gets to the surface and gets boards the boat. Safe and convenient. The rule of halves, so half usable, that's when it is safe at any time to do an ascent to the surface if somebody reaches minimum gas, but maybe not so convenient, but it's completely safe. Think about your typical Caribbean dive on a boat. So in that case, you're going to take your minimum gas, you're going to remove it from your usable gas. So usable gas is total gas minus minimum gas is going to equal usable gas. In aluminum 3000s, to use the example of 60 feet from earlier, that means we need 800 psi as minimum gas. That means my usable gas is 2200 psi in an aluminum 80 with a consumption we established 0.7. Take that number, and then you half that usable gas. So half usable gas is 1100 psi and 1100 psi. So when I use 1100 psi, it's time to turn back. That's my turn pressure. That means that my gauges are going to say 1900 psi. That's 800 for my minimum gas plus my other half. And hopefully I'll return back to the ascent line and reach it somewhere north of my minimum gas, where I'll do a normal safe ascent to the surface, get to the surface, get to my safety stop, do a normal safety stop, and then exit the water, and hopefully be on the boat with over my reserve, which we're not touching. Remember that gas does not exist. In the third rule, which is going to be the rule of thirds, it's applied differently in technical diving. We're going to talk about this as if it were just recreational. You're diving off the coast in North Carolina, and it is not safe and not convenient to do a mid-water ascent in the middle of a wreck in a current. You must use the exit and entry side. So that means I'm going up on the anchor line, because if I'm not going up on the anchor line, I'm doing a mid-water ascent, even if I shoot a bag, I'm going to be blown off the wreck, and who knows if they'll find me or when they'll find me. Or then the boat captain's going to have to unhook and leave everybody else at the wreck and go get you if they don't have a dinghy. Again, not safe, not convenient to do a mid-water ascent in case you need to. So somebody hits minimum gas, now we got to get up because now we don't have a gas for both of us to get to the surface. Well, we're screwed if we're in the middle of this wreck. So in that case, we take minimum gas out of the usable gas. So at 2200 now gets split up into 3 portions. It's not good math, right? 2200 divided by 3 is going to be 733. So that means you have 3 portions of that gas. The first third is the outbound leg, so 733. The second third is your inbound leg, coming back to your ascent line. That third is not for you. That's your dive buddy's gas. Because in case something happens on the way of the dive, you have to have enough volume for that individual to get back to the ascent line with you. Because a direct ascent to the surface is not possible for many reasons. Either a restricted overhead environment, restricted overhead traffic, boat traffic, or it could be conditions that would determine that a direct ascent to the surface would blow you too far off of your exit line. So you must use the ascent line. So to sum up the gas rules, 3 gas rules: all usable, halves, and thirds. The amount of minimum gas that you need is going to be determined by the depth that you're diving to. To calculate the amount of gas that you need, it's ascent average ATA, consumption, and ascent time. With those 3 things, you can calculate how much gas you need for you and your dive buddy to reach the surface safely. Remove that from your gas volume. So usable gas is minimum gas minus fill pressure. That gives you how much gas you have, and then you apply the gas strategy that you need according to the environment. Hopefully this was helpful in clarifying how we need to plan dives. If you have any questions, shoot me an email. See you under.